Okay, this is going to be a problem that's based on calculating molarity based off of an experiment between a weak acid, which is going to be acetic acid in this case, and sodium hydroxide. So if we go ahead and read the problem states, in a laboratory experiment involving the neutralization of vinegar, which is acetic acid, using 0.500 moles per liter of sodium hydroxide, the following data was collected. So you can look at what data was collected, but basically this is probably a titration going on here with a neutralization. So A basically just states calculate the molarity of the vinegar in each trial, okay? And you need to remember that since this is a titration or a neutralization problem, you know that you can calculate molarity. You can say molarity is equal to moles over liters, and that's ultimately how you calculate molarity. However, that's not what we're doing in this problem, right? It's a neutralization problem, so we're going to need a different equation. And the equation that we're going to use here is the equation that we end with on Friday, and that's the MEL equation, right? So if you remember, the MEL of an acid is equal to the MEL of a base. We ultimately can solve this problem, right? So we are trying to figure out the molarity of each trial here for the acid, okay? Now, we do have a volume because the table gives it to us for the acid, and we do have a molarity for the base. The problem gives it to us, right? Because moles per liter is molarity. And then we have a volume for each trial from the base. Okay, so now there's a couple of things going on here. But before we move forward, the first thing that you should be thinking about doing is writing a balanced chemical equation, right? Because we get E's from the balanced chemical equation. So that should be your first thought here. Okay, so let me write a balanced chemical equation because I need to know if these guys are going to be a 1-to-1 mole ratio, if there's going to be something different. Okay, so the table gives us acetic acid, and so acetic acid is just CH3, COOH, and then it's saying that we're doing this experiment with sodium hydroxide. So you know that sodium's +1, so we can do all this, +1. Hydroxide is -1, charges cancel, so sodium hydroxide is NaOH. Okay, since this is a neutralization, again, the problem tells us that we're neutralizing vinegar here, right? Our two products are going to be water and sodium acetate, right? Because that's going to be the salt. So sodium acetate is going to be, if you remember, so here's sodium, and then acetate is going to be CH3COO minus. That's acetate. So it's a -1 charge. So charges again cancel. So it would be Na. Here, let me scoot this over. Sorry. NaCH3COO. That's going to be sodium acetate. Now, since everything is kind of just flip-flopping and everybody has a 1 charge here, everything should kind of be balanced out here, but we should double check. Okay, so I have 1 carbon, actually 2 carbons, I'm sorry, carbon here, carbon here, carbon here, carbon here, so that's good. And then I also have 3, 4, 5 hydrogens, 2, 3, 5, and then the sodiums and the oxygens also balance out, okay? So that's going to give me E's here for, they're both going to be 1, since it's a 1-to-1 ratio, okay? So you can either put E into the equation, or you can just leave it out since it's not going to contribute to the problem at all. Okay, second thing that you need to consider here when you're calculating the molarity for each one of these trials is that acetic acid's volume is in liters, where sodium hydroxide's volume is in milliliters. Okay, now it doesn't matter which one you use here, just make sure that both the acid and the base are in the same volume. Okay, So I'm just going to make the base liters too. I just think that'd be easier. So I'm going to go 1, 2, 3. So that'll be 0.01659. And now we're talking about liters. Same thing here. 1, 2, 3. So it'll be 0.02739. I'm going to do the same thing here. 1, 2, 3. So it'll be 0.03558. Okay? All right. So now I have volume, so I can now solve for each trial. So I'm just going to do one trial, and then I'll let you solve for the rest of them. So let's go ahead and calculate for trial 1. Okay, so for trial 1, I'm just going to do, and this time, since E has been dropped because of the 1-to-1 ratio, 1 doesn't mean anything. This is basically the equation that I'm going to do, right? So the molarity of the vinegar or the acetic acid is what I'm looking for, so that's going to be my X. Okay, so for trial 1, I used 0.01000 liters, and I'm going to set that equal to the 0.500 molar for the base times 0.01659 liters. Okay. Now you'll notice that the molarity is going to limit how many significant figures we can use because it has 3 where the volumes have 4. Okay, so then the next thing that I'm going to do is plug this into my calculator. So ultimately I'm getting X by itself, so I'm going to divide both sides by this 0.1000 liters. Now you need to make sure that you do this times this before you divide by that, or you're going to get a different number. Okay, so for X, I'm going to get 0.5 times 0.01659 divided by 0.01, and I'm going to have 3 significant figures here. Okay, so the molarity of the acetic acid is going to be and I'm getting on my calculator here, you can see this, 0.8295. Okay, so I need 3 sig figs, so 5 rounds the 9 up. Right, so the 9 rounds the 2 up, so it's going to be 0.830 molar. Okay, so in trial 1, the acetic acid is going to have a 0.830 molarity. Okay, what if I asked you, kind of drawing on some previous information, how many grams is this? Can you tell me how many grams of acetic acid is in this solution? Okay. Now this is where we're going to have to use the molarity is equal to moles over liters, right? Sorry, didn't we just have the volume from this equation? Yep, here's the volume of the acid, and this is the concentration. So what can I solve for? Well, can't I solve for moles? And if you remember, moles is going to be equal to, if I was to rearrange this equation, moles is going to be equal to molarity times liters, right? So I can plug this into this equation with my numbers. So 0.830 molar times the volume that I used, which was 0.1000 liters. And it's nice, here because I'm already in liters. So you need to make sure if this was in milliliters, it would have needed to be converted for molarity because liters is used there. So moles here is going to be, if I plug this into my calculator, it'll be 0.830 times 0.01. So I get, I don't know why I just plugged that in, but 0.0830 moles of acetic acid, okay? But the question that I stated was, well, how many grams of acetic acid is this? And so that's just going to be a simple mole conversion, right? So I'm going to say question mark grams of acetic acid, which is CH3, COOH, is equal to the moles that I just calculated for molarity, which is going to be 0.0083 moles, of CH3 COOH, right? So now what you have to do is convert, right? So for every 1 mole of CH3 COOH, it's going to weigh, so let's do this really fast. So 12.01 plus 3.03 plus 12.01 plus 32 plus 1.01, and I got 60.06 is its molar mass. So I would just do 60.06 times the amount of moles that I have, which was 0.0083. And with 3 significant figures, because that's what I'm starting with, I have that this trial used 4.498 grams of acetic acid. Okay, so in this problem we did a neutralization using our Mel equation, and then from the Mel equation we're able to calculate how many grams of acetic acid was in that sample. So why don't you go ahead and try the other 2 trials and see if you can get some answers that make sense to you. Thanks.